I guess we'll get started now. So let me change display, and let me know if the volume is fine for the music and all that. And let me reset my alert thingy real quick. Okay, it should be good now. Yeah, so in this stream I'm gonna try to start working on creating a WACCA simulator chart visualizer kind of thing. So I'm gonna be using MonoGame, which is like a game framework. I have all these things in the description. So yeah, this is the main start. Mainly today, probably we're gonna be working on shaders mostly. Created this like presentation that we can show right here. These are some of the note like the note types that we would have to implement in it. So we've got this touch note, just a standard note. You can see it's got two caps, one on each end, unless it goes around fully in a circle, and it's got this like dark shading kind of on it. We've got hold notes. They kind of start with like a yellow, or well, technically you can change the color of any of these in the actual game. But they kind of start with this yellow bar, which is basically the same as the touch note. And then they have this trail, and then they have this ending piece, as you can see on the right image. Then here's some more images of the hold notes. Most of these images are not of the most recent update of the game. I don't think they've changed it much, and it would be probably more dependent on the chart you're playing based on how it looks. So yeah, this is in the top left. It's kind of like one of the slide notes, I believe it's called, with the hold note after it. So they can start with any kind of note. So I guess the main one standard one would start with like a standard touch note. And here's a picture of it changing like the direction it's going, and also having a chain note, which we'll get to next, I think. And also on the on this image, you can see when multiple notes are at the same time, they kind of like draw this border around it. These are kind of overlapping in a strange way. But that's sort of to show how they blend. And then, as I mentioned previously, there's the chain note. They kind of look like the standard note, but they got like this sliced pattern on it. I found it interesting. On the image on the right, there's like some weird stuff happening on the top instead of them just following the pattern all the way around. I don't know if that's due to the pattern not properly like fitting if it goes all the way around or something. But yeah, and then there's the slide notes. So these you either have the clockwise or the counterclockwise, and you can see what direction by the arrow and the color. They kind of look like a normal note, except for they have this little arrow on it, and they are often a different color. The one on the left here, I don't know if you could see it, but it's got these dark triangles on it. That's something we'll get to next. Here's a full circle one to sort of show how it like tapers off right here, and then it goes back to that size. And there's, similar to the slide notes, there's the snap notes. I think my music stopped for some reason. That's just at the end of the song. So these notes, instead of like going around, you push forward or backwards. They got the arrows pointing in or out. Let me see if so I have the blue one as well. So they also use that same like note style. And you can see also when they're together, you can see there's this line between them, which we didn't see on the previous hold note image. So they have the line around them, and they have the double line between them. So those are some things that are consistent among like all the notes, I think. And they also don't connect right here, it looks like. Yeah, so here's just the blue ones. You can tell they use the same exact blue cap, it feels like. And there's one that's a full circle, followed by, I think, basically this, but just, yeah, basically that. And then there's the R note. These are newer to the game. Let me make sure I have chat open, yeah. So these kind of have like a glow around them. It was hard to get a good image of one on a standard note, but I found some with these slide notes and snap notes. So you could see it, especially on the right image, that they have like this glow around them, and they create like a rainbow grid. You could sort of see it forming on this image. I'm not sure if we'll get to that today, or how much we'll be even able to get to today. Yeah, so the bonus note is that like triangle pattern. It might be hard to see the one on the right image. Personally, on the monitor I'm on, I can't really see the triangles on that. I don't know if YouTube stream quality will make it hard to see that, but there are triangles on this pink note, just in the same way that there are triangles on these notes right here. And here's a picture of a full circle with the triangles on it. Again, I can't really see it on the monitor that I am on. And this is a link to a website. I think I also might have put it in the description. Let me check. No, I didn't. Let me put that in the description real quick. So that web page, let me see. Yeah, so that page is the kind of like a wiki, which gave me the names of the notes basically, so I knew what to call them. So I'm adding it to the description now. Okay. So I guess we can get started with, let me see what note would be the best to start with. So we've got the standard touch note. I guess we could start with that, but I think the yellow part on this hold note might be another thing we can start with. So I'm gonna pull up a drawing app so we can make a little sketch on how we're gonna do this. Okay, so with MonoGame, I think you program in HLSL shaders, I believe. And basically we need to use a polar coordinate system, so like a standard coordinate system using the texture coordinate would have 0, 0 here, and then 1, 0, and 0, 1, 1, 1, basically. And that would be the standard. We're just kind of going to wrap it around so it goes, it's kind of hard to draw something circular, I guess. But the angle that you go around is the X value, and the amount out is the Y, I believe, is what we're gonna do. I know the drawing doesn't really help too much, but that's the general idea. And I'm still getting used to programming shaders, so I might not do it in like the best exact way. But yeah, we'll see. And then, so basically we're changing the coordinate system since the game, let me pull up that image again. Since these notes, you can see they have an infinitely small vanishing point. That basically requires us to do this polar system if we want to do it easily. Like previously I created a note that looked similar to this in Unity, and I did it with mesh generation. It didn't really turn out the best. Well, it worked, but it wasn't the best solution, and I think the polar coordinate solution is probably the better solution. So we're going to input into the note, we're going to have the values of the start and end of each side of it. You can, let me pull that up again. You can see some of these crazy shapes. I think they are built up, especially if you view this image, I think they're built up of multiple of these note zone basically things. So basically we'll just make a simple one that goes linear between the points, and then if we want to make more complicated shapes, we'll go into the C# code and create a bunch of these shapes to create the more, I guess, compound shapes. So I'm gonna start with this example. So let's say we have something like this shape where this is 0 and this is 1. Remember this line right here at the bottom is going to be this infinite vanishing point, and we're going to move it out. So basically transform it on the y-axis if y-axis is out. So that basically gives us that effect. So let me label 1 there. So let's just say this is the note shape that we input. Let's just say that's 0.1 and 0.5 or something, and then 0.3 and 0.5. So we're going to wrap that around. We're going to need to input in these values at the bottom here and these values at the top. So we're going to have let's see, we're going to have start, actually it'd be easier to just probably write it in code. So I'm going to start by loading up the code here. And we need to create like a basic kind of like square that we can test the thing. Let me see if I can find some code that I've done before that might make it easier to start this. Actually, I'll just make a new, because basically with MonoGame, in order to do anything, you need a texture. So I'm just going to create like a little white square texture that we can use. It's going to be replaced entirely by the shader. But I believe you need to have a texture for MonoGame to even work and place objects. So just making that image on a second screen right now. Yep. I'm going to import it into the project. Okay, yeah. So now I have, actually let me add the Solution Explorer to this window right here, so you can see that. So yeah, we got this drawing right here, untitled drawing. I should really rename that. Actually, I'm going to delete it because I'm not sure how it interacts. Actually, I'm just going to delete it and rename it and re-import it, because renaming something in a program might cause some errors. Yeah, so I'm gonna add that back in now. Okay, I'm gonna build that real quick. Okay, yeah, so now we have white square.png. As you can see, it's just plain white square. Why did that change to the toolbox? Okay, so now we need to place the object. So I think you need to create a sprite batch.begin and then a sprite batch.draw. Okay, and in this you need to specify the texture, the rectangle, which is like kind of like the coordinate of where it is, and the width and height. And yeah, so let's start by, actually we need to import our texture. So we're going to create a texture 2D and call it white square, because that's kind of what it is. And then in our load content, we're gonna do, is it content.load? I can't remember exactly. And then we need the name of it. Actually, we need content.load with this, so we can tell it what kind, I think. And then the name of it is white square. We don't put the .png on this, I don't think. We actually have to assign this to this. So there we go. So I believe that's correct. Let's just try drawing white square and a new rectangle. And that rectangle will kind of fill up the whole screen. So new rectangle 0, 0. So that's the starting position. I believe it's a top left coordinate. I know I drew bottom left on this drawing, but I believe MonoGame is a top left coordinate system. So we're gonna do, let me see, it was the white square graphics device manager. Let me just try. I'm trying to find the height of the screen, basically. I can't remember. It was, I feel like it was graphics device .viewport .width. I guess that's right. Okay, so graphics device viewport height. Let me see what's wrong. It needs the color, I think. So basically this color just multiplies this color by whatever you put in here. So for example, if we wanted to change the color, or like multiply the color of the entire shader, instead of having to like put in a shader parameter, we can just multiply it by this right here. So let me, okay, so this will be a test to see if I did it right. So we're setting the background color basically to black. We're beginning our sprite batch. We're drawing our white square, which should fill up the whole screen. Then we're ending our sprite batch. So let me run that real quick and see if I did that all right. It looks like it's all white, so I think that worked. I'm not quite sure why it changed my windows around when I did that. Oops, wrong window, this one. But yeah, I think that worked. Next thing I want to do is I want to lock the what's it, the screen dimensions. I want to lock them to like a square aspect ratio. I'm just going to put in specific coordinates. So I can't remember exactly how to do it. Let me look it up real quick. Okay, so it's in this, probably in the initializer. Yeah. So the graphics dot preferred buffer width. Let's just set that to 1000. What's wrong with that? Oh, there we go. And then we'll change this to height. Okay. And then let me run that again, and hopefully it doesn't change my windows around every time I have to run it. Okay, it looks like that worked. Yes, now we got a square. I'm gonna shrink it down because I'm running on a 1080p display. And that's filling up almost my whole screen. So let me, there we go. So now we got this window. that we can test with to make the shader. So let me create the shader file real quick and we'll see if we can get started with that. So I'm going to open up content right here and create a new item effect. We'll just call this hold note. And this will be the kind of the yellow part, I guess you could say, not like the start of the note, and not like the trailing piece, but like the middle section. So I'm going to create that. I'm going to save and build. So it should show up now. Yep, so it is right here. I can't remember what version we need for like having more functions, but I'll just leave this on this for now. I think you would change it to a 3, but I'm not too sure if you want more to change it to a higher version. We don't need this. We don't need this. We don't need this. And we don't need this. So basically what I just did, I removed all of the vertex shader, which kind of like works on every vertex. And now we're basically left with a pixel shader, which runs on every pixel basically. So let me refresh something. Of course, my YouTube Studio decided to not let me view the stream stats. Okay. Yeah, so this pixel shader here, right now it's just returning input.color. We don't really need that. Well, first we need to get in the texture coordinate, I believe, so we can get the coordinate system of the texture. Instead of getting the coordinate system of the world, we want like of the texture, because that way when we scale this object it doesn't mess everything up. So let me see if I can get that YouTube stats back up. Okay, there we go. I got it back up. Hopefully the stream's still running okay. Let me know if anything happens that's wrong. So we're gonna create UV. So UV is basically just the coordinate, typically referenced to like textures. So like if you have a texture on an object, you want to say, so this corner is this point on the texture and this corner is this point on the texture. So you basically map out how the texture is on each face or like triangle of a model. So let me see. I think it's like this. I can't remember to be too sure. Let me, instead of this, so basically what the pixel shader is doing here, a float 4 is basically a color. So it's the RGB and alpha values. Okay, yeah, everything seems fine. Okay, good. So it's the RGB and alpha values, I believe from 0 to 1. So we're going to comment out this return real quick. And we're going to return, and with this shader language, you don't need to use the new keyword. You could just call it like this. So we're just going to do 1, 1, 0. I can't remember if this last value is fully opaque or transparent at 0 or 1, but let's just give it a 0.5 for now. So either way, we'd get something. And then in this game file right here, in the sprite batch, we do effect, and then we have to import our effect up here. So they call it effects instead of shaders in this basically. So we're going to do private effect hold note, Probably just name it the same as our file to make it a little easier on us. And then I'm gonna duplicate this content.load hold, or not hold, no, effect. And in here we'll just say hold note. There we go. And this should let me do this. Let me build it and run and see if that actually worked. Okay, yeah, there we go. So now for every pixel, it's returning this yellowish color. So it's red and green and half this value. Let me set that to 1 and rebuild and run. So I can figure out if it's 1 being fully transparent or 0 being. Okay, so that's fully yellow, it looks like. Let's try running that as 0. Looks like that's doing the same thing. I think oftentimes I'd have to set the other ones. We can play around with that a little bit later until we get it. So we got our texture coordinate. So the first thing, I already copied, I got this code for creating the polar coordinates. I copied it here. So we're gonna create kind of like a function. So we have our standard coordinate grid, which is kind of like a flat kind of thing. And then we have the this function, which basically uses trigonometry to sort of turn it into a, I guess, spherical, or I guess circular grid. I changed up this function a little bit since what I found. So basically, here's the note that I gave myself for it. So you subtract 0.5 from texture chords to get to the center. So let's just test this out by saying, I hate how the formatting tool of this does that. Let's see, float for, so we're just going to create an output variable there, and then might as well initialize it, create the brackets for this. So output equals float for 111. Let's actually make that a different color so that we know that it's not just the plain white that we had before. And we're gonna say, let me pull up chat again, it keeps disappearing on me. Actually, I'm just gonna put it in a different window. Yeah, so if the uv dot x, it doesn't like this uv is not declared. Oh, because you have to call it from input. So basically input, this right here, is what you get from the vertex shader. And what I'm telling the vertex shader to output is this. And MonoGame, I think, handles it behind the scenes so that the vertex shader gives me these values. These are sort of a hint on what the value should be, I believe. So it knows what to assign to it. So we're going to do input.uv.x, or you could do, I guess you can't do U, but they have RGB as like values which also align with XYZ. If the value of X is greater than 0.5, then output equals, this is not like the final code, I'm just doing this so we can test it. So we'll just give it a red color. And then we're returning output. So this currently is not using this polar system. So let's run that and make sure that, so in theory what it should do is it should color the top half of the screen this color and the bottom half this color. So let me run that real quick and see if that works. Oh, yeah, I guess it was the X value, so it'd be the left and right side. Yeah, so you can see the output, the initialized value is this like magenta color right here. And since x is less than 5, it outputs that color. But when x is greater than 5, well, less than or equal to 5 for this. And when x is greater than 5, it is this red color, which is right here. So then we're going to change this to be a polar grid just to see if that function is working properly. And the polar grid defaults to having the corner be the thing. So as the note here, I said subtract this. So I'm going to create polar chords, and this is going to be a float 2, because a float 2 is just 2 values, so it's like an x and a y basically. So polar chords, and then we're going to set that, let's see, yeah, so we're going to set that equal to polar, and then we're going to put in the Cartesian coordinates, so like that's like the standard coordinate grid, so input.uv, and that's a float 2, as you can see right here. And then we're going to put in the angle % offset, so that's like the rotation. I don't know why I have that in there. I can't remember what that was for. That, I think that just rotates it. We'll just put in a 0 for now. And then we're going to do this based off of polar coordinates. So instead of input.uv.x, we're going to do polar coordinates.x, since we inputted in that value here, and it changes it to polar. We should see a similar thing. Let me change this to 0.2 just in case it goes around. So this is basically like this drawing I did up here. It converted it to that. So let's run that, make sure that's working. And of course it's not. So when it's greater than 0.2, since this polar chords is a value itself, we can also show that as the color. So I'm going to comment all this out. I know I could probably just put this return and it would just skip all the rest of it. But it might complain to me about stuff after the return. So this time we're just going to output polar coordinates.x. So I'm going to run that real quick. That doesn't seem to be what I want. I think I forgot to add what this says. So subtract from texture coordinates. So I have to subtract that from this, I think. Let me see if that, actually I can't remember if you have to put F. There we go. Yeah, so now you can see it goes from, so we were basically in this bottom left or bottom right corner because we basically moved the grid. So this center area was in the top left because that was 0, 0. We moved it to be center based 0, 0. So it's more like a coordinate grid system where negative, the 4 quadrants basically. So we moved it to the center, and you can see it starts at complete 0 at this part, and then as you move around it gets closer and closer to 1. And let me show you, if I do, instead of x, if we do y, so y, according to my graph right here, is like going outwards. So let's run that real quick. Yeah, so you could see now, as you're closer to the center, that's 0, because that's closer to 0, 0, because we moved 0, 0 to the center. And as you get closer to 1 unit away from the center, actually I think it's 0.5. I might have scaled it so it's 0.5 units. Let's test that real quick. So if polar coordinates.y is greater than 1. So this, I can't remember if the script scales it so that 1 is at the edge. There we go. Yeah, so 1 unit is at the edge, so it's 2 units wide. But we don't need to worry about that since it's kind of wrapped around our square basically. So I'm going to actually change this to X. And we're going to do something a little different. I think this angle % offset, remember this doesn't change the whole coordinate system directly into that polar system. It basically, per every coordinate that we give to it, it calculates what that coordinate is, and the graphics card puts that pixel at the right spot. So what we're going to do is we're going to add to the X the Y value. So this should twist it, I think. Let's see. Or actually it didn't do anything. So if the X, oh yeah, because we're doing this circle. So let's do if X is less than 0.1, and we probably don't need this. X is greater than 0. We probably don't need this greater than 0 since it cuts off, I believe, but we can put it in there anyway. It didn't look like it twisted it, but you could see that right there. Oh, but that's silly because I didn't do anything to the grid system. This needs to be a plus equals. I was just making some strange statement there. Looks like that scaled it kind of strangely. Anyway, that's not the point. So that converts it to the polar system. Next, we need to have some input variables. So note. So we're gonna have. I'm trying to think of the best name to call this. Corners. I'm just going to give it some initial values for now. We're going to interface with this variable through code so we can tell it what the positions should be, and this is basically going to be these positions right here. Actually, let me pull out my stylus again. So it's going to be that variable is going to hold these positions and these positions. Those are 4 variables. So I'm just going to store it in this float 4 that I've created right here. So let's kind of just copy what I did on here. So 0.1, 0.5, 0.3, 0.5, 3.5. I'm just gonna add zeros so it looks a little nicer, I guess. Yeah, so we got the values that we kind of scratched into here, so we can test that. So now this is when it gets a little more complicated because we have to do something called sign distance field if we want it. So we could just theoretically say if it's less than this or if it's greater than this. But we'd run into the problem of the having no anti-aliasing, so the edges of things will look kind of like pixelated, kind of, and kind of rough. So in order for us to get that, in order to like fake anti-aliasing a little bit in the shader, I've tried doing it with like this less than and equal kind of thing, and when I put it in here and make sure that anti-aliasing is on, it just doesn't affect the shader output. So we kind of need to do that in here. So let me pull up this graph again. Where's my stylus? Not sure why it's not letting me zoom out and stuff. Okay, there we go. Yeah, so the sign distance field, like a very basic sign distance field, we practically already made one with the polar system.y. So it basically defines how close you are to the edge of a shape. So like if you have this box, and then let's just say we're talking about this coordinate right here, it's going to return this distance. And this will be a, I think, positive value. And if you have this value right here, it's going to be a negative value, I think. I can't remember exactly. But it basically determines how close you are to the edge, the nearest edge of the shape. So if we're out here, it'd be like that. Yeah, we're kind of going to like create a basic one for this. Now, with our system right here, we basically need to calculate, this is, I don't know if this would be technically a signed distance field, but it will give the same effect as one basically. So we'll have this center line. So we have our center line, and then the distance from that center line, we'll just use that. I don't think it's technically a signed distance field if it's that, but it as you get further from this line, actually, yeah. So you add, you'll get the, yeah, I can't remember how I did it before. But basically we need to calculate how far you are away from these edges. I wish I saved the code I made before for this. So if you input in this value right here, it's going to give you this plus this, I think. Yeah, so we need to subtract the value of how far away this is from the center, and then that's the distance. Yeah, so we have our point here. We subtract this section in the middle here. You can think of that as kind of moving it in, and that's how far away it is from this edge, I believe. So let me see, would that work on this side too? I think so. I think we only need to work on this axis. I don't think we need to do any other axes, because this point would be as close as it is to this. Technically this might be closer to this than this though. I don't think it would really matter too much. We can give it a try. So this is the part that makes your head think a little bit more. So we've got, okay, let's see. So first we want to calculate the center line. So the center line would be the average. Actually, we want to make, I think I remembered a little more of the code I did before. So there's a function called lerp, which is called linear interpolation. So you give it two values, like 1 and 8, for example, and then you say, what's the value that's 0.7 of the way between them? So you input in a value between 0 and 1, basically, and then it gives you the value between those. We can use that to get the value of the edge at any given x coordinate. Since we have this value, let me write a little comment above it. x1, wait, so this is the close one, close to, far one, and far two. Actually, I'm gonna make these line up a little more. Yeah, so this first value is, let me write it on my thing. I mean, I can technically change this. Okay. Oh, I have to draw in order to move around. So this value I'm saying is x1, or not x1, c1. Let me erase that. And this one I'm saying is c2. I don't think this is like proper naming standards, but I'm just giving these so we can understand. F1 and F2. So that's what those variables are in that vector 4, or not vector 4, float 4. And then, yeah, so basically when we're doing this linear interpolation, the way this will come into play is the percent that you are down, or like the 0 to 1 value that you are down this note. It will go between this 0.1 and this 0.3. So halfway in between would be 0.3 plus 0.1 divided by 2 or whatever. Mental math. So we're going to do... There's probably a more efficient way to do all this, but this is just the way I'm going to do it for now. So this is going to be just a standard float, basically. Actually, I just remembered. Yeah, so... Yeah, let me write this down real quick. So using this coordinate system right here, let me just write how it goes around, basically. This value, this line right here, where it's 0 and 1 right next to it. So normally you would have like a fade. I don't know if I can draw a fade in this application. You sort of see a fade in that. So normally you would have a fade on the edge for like the anti-aliasing faking kind of thing. But for this, when you get to this edge, it's just going to cut it off right down the middle. So you're not going to get any anti-aliasing, and it's just going to be a cut. So basically we have to add 0.5, so our note is always on this other edge. I don't know if that makes any sense. It's going to have to always be on the other edge of our coordinate system. And I think... Can't remember if I want the center line to be there or this C1 value. Well, actually, either way, we're just going to, behind the scenes, add this to it and then subtract. So basically what we're going to do here, let me see. So the reason I added this add value right here is that value will give us, I think this value would kind of twist the thing. Let me try. It's kind of, I kind of need this variable to be already there for me to use this. So let me add a 2 to this, and then this is just to show. So I believe this second, or this value right here, I'm rotating it by that. So I'm rotating it by the distance from the center, so that should create a swirl, which is what I was trying to do before. Return polar chords 2 dot x, I believe. That should swirl because I believe this y adds to the x value. Yeah, you could see up here, this is the output value of the polar function, and it's going to return this is the x value, and I have that variable affecting the x value. So let's run it and see if that does anything. Yeah, so you can see now it twists. So basically we're gonna have to rotate. I think I'm starting to remember what I did before. Another key thing, reason why we're twisting this rather than doing it another way, is when we make a hold note. So some of the hold notes could like spin all the way around more than 360 degrees. If we're just keeping this axis right here at the same, it will do this cutoff thing, and our notes will not be able to go around more than that. So currently, if we don't rotate it, our notes would only be able to go around like that if that's our axis, basically. But if we basically move this axis around, our notes can go further, sort of. It's hard to describe necessarily. Let me remove those. Yeah, so we got to keep our notes in this 0.5 zone and then add that around. So I think actually we will add by this first value and then have this value go out. I don't need this second polar chords anymore, but but we will need to do some math before the polar chords, I think. So we need to get the so the left extent and the, actually let's name it first extent. So this is going to be the value per the coordinate that is closest to this left, so the closest to the 0. And basically we're going to subtract that so that it lines up, or we're going to add 0.5 to that, and then we're going to make it be the center line basically. So let me load that up. And we also need a, I'm just going to add a semicolon so it doesn't, so I can write the next thing. So actually start extent, end extent. So start extent is basically, we're going to use that lerp function. Actually, I have to do an equals. I don't know why I forgot that. And also a value type. So this is going to be just a standard float because it's just one value basically. So we're going to do, and this lerp is a built-in function of the shading language that I'm using here. So we're going to provide in, let me see. Yeah, so float x, y, and s, you could see it says performs linear interpolation, x the first floating point value. So that's basically what I was saying before. So we're going to input in our corners.x, corners.y, actually not, corners.z. So this will give us, and actually we're going to also provide, we're going to have a note position, I guess. Yeah, so this will provide us with between the C1 and F1 value, so X, Y, Z. So X and Z. So it's going to give us the value between these based off the progress we are through drawing the note. I'm going to kind of copy this for the end extent. Equals corners dot y, corners dot w, I think. Is this the w value? Yeah, so it says x, y, z, w. I think there's another, like you could probably put a in there as well. I'm just going to use w because, so this will give us the y and the w, so x, y, and z, w. So it's going to be the C2 and the F2. So those are those define this edge right here. So the C2 and the F2, so that defines this far edge. And the F1 and the C1 defines the closer edge. Okay. Yeah, so we have our start extent and our end extent. And we want our note probably have the start extent be the position of the coordinate system start plus 0.5 because the issue I mentioned previously. So this value right here that we input into polar chords, we're going to put in the start extent. And that's going to make it, actually we're going to do start extent plus 0.5. So that's going to give us the, we might actually have to do subtract 0.5, but I'll have to see when we actually test it out. So that's going to move it to over here and then add whatever position this is. So this is the new 0 degrees. I can't really draw with my mouse. Where's my stylus? Okay, there we go. So that's the new 0 degrees, and then, well, it's technically in radians, but I guess 0 is technically a radians value. So this 0.1, we're gonna have to, I can't remember if my polar, yeah, so actually it's not in radians because I do this right here. I change it from a radian system to a 0 to one system. So we don't need to worry about degrees as much as we need to worry about 0 to 1. So that's what this part of the function right here does. Yeah, so if we're at 0.1, that's basically right here, maybe. I don't know, I'm just making it up. And then that's there. So basically what we did is we added this value to whatever x, ignore the fact that that's not a circle. So we added that to whatever x value it is. And then what we'll do later is we'll subtract or like rotate it around. Actually, I think we need to rotate. Instead of adding, we probably need to subtract and then add later. Let's just change that to a minus for now. I'm gonna remove this f because I don't think specifying it's a float is required. It might be a good practice though. I'm not too sure. So now we have our start extent and our end extent. So our width is equal to actually it's end extent minus start extent. And in theory, the start extent will always be less than the end extent, unless we mess up when we're inputting in values, because that would imply with this graph right here that we'd be doing something like this instead of something like this, basically. But yeah, as long as we input in proper values into it, we should be fine. So now we're doing this subtract, and then I'm gonna kind of reuse this code to test what we have so far. So we have our output. This is like the initialized return variable. I'm gonna remove this return that there was before. And then if the polar chords.x, I'm gonna change this to say greater than 0. And this is not proper yet. What we would need to do is smoothly change it between this color and this color when you're within a certain range of the edge of the note. So this is not, actually I'm gonna change this to 0.5, I think. Yeah, we'll see if it works. We might need to run, I see this has a fraction right here. We might need to run this polar chords through a fraction as well, which allows it to repeat basically. We'll just test with this for now, and then .x is less than 0.5 plus width, maybe. Technically the 0.5 could be a different number, but I don't know if I did this right. I guess we can run it and see what happens. So I'm gonna close the window and start it up. It says there was build errors. Yeah, it's running the previous build. What was the error? Let's see. The command exited with a code 1. I think, let's see. This is the trouble with shaders. It's kind of hard to see what we did wrong necessarily. I'm going to comment out this to see if that's the error. So now it should just return this color. So we're kind of simplifying how much we're using of the function. Okay, there we go. So the error was caused in this area right here, or not. Something in this it's calling is causing the problem. So let's see. So polar chords x. Let's Actually, before we do that, let's see what our polar coordinate system is looking like, because basically we added the start extent to it, and we also moved it back 0.5. I don't know if this is the right spot to do this 0.5, but I guess we'll experiment around and see if that's working correctly. So we're gonna do polar coordinates dot, actually, return polar coordinates dot x. And this output, it won't do anything because we're already returning up here. Okay, so let's run that. It says there were build errors. So it doesn't like it when I reference, so like the compiler of this kind of does some sneaky things, and it doesn't use what you put in if it's not being used. Sort of. Like if you don't use this variable down here and you try to reference it from something else, it will just cause an error. So I don't know if it's an issue with that or it doesn't like this. Should I put the F back onto that? Nope, that didn't work either. Let's try returning with. So that's kind of skipping this polar coordinates value. Okay, so it doesn't like that either. Let's try changing the shading to 3. No. I think that was 1 before, right? Yeah. Okay, nice. Variable output is not declared. It's giving me an error for that. I mean, I could try canceling that out, but yeah, that's not the only error. Exited with a code of 1. Actually, I think the this content thing gives me better information than the Visual Studio. It says failed to compile. Variable note pause used without having been completely initialized. Oh, this right here. It doesn't like this. That was what it was not liking. Note pause equals input dot y. So basically, actually not input dot uv dot y. There we go. So that's going to be our progress of our note for now. And now that shouldn't cause an error, right? Let's see. Yeah, so progress, or the width right here. I'm going to uncomment out what we had before. Let's see if that does anything different. Okay, so we get this right here. I believe that's actually correct. So we're going from this 0.5 value right here. So we have our 0.5. So that's 0.5 on both sides. Let me change that to 0.4 so we can see this a little better maybe. Because right now 0.5 is this like straight across value, I believe. Yeah, there we go. So now that's 0.4 of the way around the circle. This first value, 0.1, you could see it's 0.1 away around the circle, I believe. The second value for that's 0.3. So that's 0.3 around the circle, but it's infinitely small. So you can't really see it, but you could sort of see the curve it goes to get to that 0.3 value. So I think we did that correct so far. Now we're getting to the point where we might need to start interacting with it through C#. Actually, I just realized I wasn't recording this whole time, but I don't need to record. Yeah, so we might need to interact with it through C# so we can play around with this note position. But for now, I'm just going to add 0.3 to it so we might be able to see the other edge of the note. Actually, there are no edges yet. Let me see. We're going to add another check in here. So we're going to also use and. So we have, if it's within the width, remember this is not correct, what we're going to use finally. But this is like saying if it's within that. In reality, we're going to use have it smoothly go between them, but for now this is what we'll use to test it. So, and the note pause is greater than or equal to 0, and note pause is less than or equal to 1. So that's going to sort of clamp our note within the extent of the note pause, the note position, or not, unless I subtracted the wrong way. Wait, so note position is the input.uv.y. So I think we're using, since we are wrapping the, I need to get this window to let me interact with it. It's glitching out on me. Okay, whatever. So we need to get the, it closed all my windows on me. Yeah. So the Y position, the Y coordinate influences the progress through the note, basically. That's what we're trying to do. So that's why I'm using input.uv.y. It doesn't matter if it's before or after this polar in terms of things, I think, because this uv.y would mean the same thing in both scenarios. Let's see, so input.uvy. If it's greater than 0 and less than 1. I'm not quite sure why. Let's try just overriding if it's, if note pause is greater than 1. Let's just try that for now. And then out, I'm just gonna copy this line because that'll make it easier. We're going to give it this, actually we'll just make it all black. I think that's all black. Let's give that a try. Okay. So it might need to be on the other, after the polar chords. Okay, yeah, and we'll use a remap function probably to get this note pause to work for notes that are longer than 1 unit. Okay, it didn't like that. What did it not like? Note pause is not declared. Oh, it's being used up here. Okay. So if note pause is greater than 1, okay, so we might need to create, I don't really want to do that calculation twice for the polar coordinates, because that, with GPU programming, you don't want to overdo it for every single pixel. Basically, we want to minimize what we're doing. So if note pause, okay, so if the Y value of the input, and then we're going to say if note pause, actually it's funny with shaders, the simplest things get the most confusing most of the time. That's before that. So this is kind of acting as a separate thing right here, which is why you could see it was coloring in the bottom section. Only the bottom section, really. I think we might need to make a new note pause for this. That'd probably be the easiest way to get this tested real quick. Let's give that a try. Because now the second note pause is using the polar system. There we go. So you could see the extent of it. Since we added 0.3, there's a note, I think that might have pulled it in. Let's try subtracting 0.3. Yeah, I'm not too sure about that. Oh, we're using the pause. Yeah, it's greater than 1. I'm not sure why it's doing the same kind of thing each time. Let's see if it's greater than 1. Well, so either way, we're going to be shifting this polar coordinate system around. Let's probably integrate that with C# for now. So we have our game here. I believe you put parameters in here. Actually, no, you don't. You interface with it. So let's see. Let's add some keys so we can press some keys. Get state is key down. Keys dot. I'm not sure if you can use arrow keys. Not that I need to necessarily, but I'll just use W because it's similar enough to arrow keys. And then we'll have a S. So this will like move the progress of the note. I'm gonna create a variable up here. So this is going to be, and not everything will go into this file in the end probably. We're just using this so we can test the shaders for now. So we got a float. This is going to be progress note progress test. I'm just going to put test on there so I know that it is just a test. We're going to have to add in a note progress note start progress equals 0 float note end progress equals 1. Okay, so this, we're going to define the edges of the note, how far they are along in the note basically, and that probably fixes our issue that we have with whatever we were doing here a little bit. We might need to modify this note position right here. And actually, we might not be able to use this rotate with our start extent. We might need to add, we might need to rotate it afterwards so we can have this be after the polar coordinates so that this note position can rely on the value outputted by this polar coordinates. So we might need to redo that a little bit, but for now, I'm just going to play around with this note start progress. So I can't remember. So let's see. Yeah, so we got a parameters function. I think it's an array actually. So we're gonna do note start progress, and then you just, or dictionary, I guess that would be more accurately, to set value. So we're gonna do note progress test for that one. And then for this one, actually, we need to multiply that. Actually, these are consistent. 0.5f. Yeah, so these aren't actually changing the value. So we need to do note progress test plus equals 0.1. I'm not going to worry too much about multiplying it by the game time for now, because this is just a test. Wait, what am I doing? This needs to be in both of these. And again, that's repeated code, but it would probably be better in a function. But for now, this is what I'm just going to test with. I mean, I could move it out of this, but let's give that a try. Actually, these values, that would give an error probably. These values are not being used down here. So when it compiles, it's going to remove these values from the code. And then this is going to throw an error because this doesn't exist. So we're going to have to use it in some way. So we're going to say if the... Actually, I'm going to do that change now where we move this to the top. So the start extent we're going to remove out of there. And then polar chords dot x plus equals start extent. And this is going to use polar chords dot y. Okay, so that basically what I did, I moved the polar chords up to the top, so that gets calculated first, so that our note position can rely on that. And this value right here is actually going to be start or note start progress. Actually, I don't even know if I need that. So this value, I might need to use a lerp for this, but let's see. So we have this note position is supposed to be a 0 to 1, or at least the range of the note should be within 0 to 1. So these start extent and end extents with their lerp can work. So this note position is the progress through the note basically. So let's see, polar chords dot y, that's the progress through the map, plus start note progress. I think instead of this, we'll need to calculate a start extent. Why am I adding start extent? Oh yeah, that rotates it. Okay. I'm trying to think if we need to calculate a... Actually, we have start and end right here. This would be more accurate to call this note progress, because that's a better, like a more accurate name. So this is if note progress is greater than 0, so between 0 and 1. So actually, I don't think this should be note progress. Actually, yeah. So this is for every value we pass in. It's going to output the progress through the note. I think so. We actually need an inverse lerp, which I don't think is built into the shader language. Let's see. Let's see if it is actually in here. So I'm going to duplicate this, comment it out, and is inverse lerp a thing? No. I see a lerp. Okay, that's not a thing. Oh, I see the function that they pass in. Okay, so this is a function I found, inverse slurp. So from to value, yeah. I would normally not like copy code from online, but it's like so simple and it's just like basic math that there's not really any other way to do it really. So I think it's fine in this instance. So the note progress will be the UV, not the UV, the polar chords.y. That's going to be the value that goes between the two values. So that will be the last value. So this first value is going to be note start progress, I believe. The second value is note end progress. Oops. Is that all fine? Yes, so that will give us, so the inverse lerp, what it does, I don't think my drawing thing's gonna let me do anything anymore. I'm just gonna restart it. There we go. Okay. So the lerp brings you between these two values. The inverse lerp, what it will do, you give it two values. So for example, 0 and 10, and then you give it a value in between it. So if you give it a 5, I believe it would output 0.5. So it converts it from these values and then gives you the 0 to 1 value for that. So I'm going to go back in. So that's a little description of what the inverse lerp does. So we're basically saying this is the start value, this is the end value. So our progress of the note, which is what we control through C#. So that's going to basically control the edge of our note. And then we're going to pass in this value. So it's the value that's in between. So what is the value that we are, let me remove this if. So what is the value that we are in between? So this is the value of how far we are throughout the circle. And this is the two values. So that should give us a 0 to 1 of how, if we are within the range of the note. Let me see if that actually works. Let's try running that. I'm going to click play and let's see. I think that actually might have worked. Let's see if my parameter works. Oh yeah, my parameter does work. Except the outer extent doesn't work. The note progress ending. Let me slow down. Let me slow this down a bit, because it is based off frame timing a little bit, so how fast the frames are. So I have to have it very slow because it does that for every frame. I believe MonoGame on default locks it to 60 FPS. But yeah, you can see, I don't know why this edge is staying put. I don't know if that's a problem with my C# code or, oh yeah, I'm saying note start progress. Let me make sure that that's what it's called. Copy that over. Yeah, so that was a problem with my, oops, keyboard mount function. So note end progress. Let me give that a try. Yeah. So that's kind of giving us a little bit of the effect we're looking for. Let's change these values so it looks more kind of like what we want. I'm going to try making it twist, so I'm going to start it at 0. And I'm going to go to 2. So the C2, actually no, not to 2. This is the second part of that, so to 0.1. So this is going to do 2 and then 2.1. So it should do multiple rotations, and this right here, we're only adding 0.5. So we're going to, so this is basically the length of the note right now, the way it's implemented. So the far edge is now 1 unit away from the inner edge. So that kind of, when we're doing the programming for this on the actual game, that'll influence the length of the note, I believe. Okay. So let's see if this is... Okay, so you could see it is getting cut off. So we probably need to... I wouldn't imagine it to be needing a fraction, because we are rotating it here. Let's try something simpler so we can, instead of stress testing it. Okay, this should be a lot simpler of a thing to test with. Okay, so I can already tell right away the degrees is going the wrong way, but I believe it is roughly working. And to make it easier to see, I'm going to, if polar chords.y is greater than 1 output, I'm just going to put it in. This is going to kind of lock it to a circle, so that we don't see it like extending beyond. Let me give that a play. Okay, there we go. Yes, that's kind of giving us the effect in the game that we're looking for. You could see the start. Actually, I think I reversed it, so the start is actually the end and the end is actually the start. I don't know if you can see that, but I believe this end is the start. Let's try changing the value to be really thin on this start area, 0.04 or something, and we'll see which end of it gets shrunk, because I think I might have reversed them. Yeah, so the start is actually the end, so I really need to rename. So the note start progress, can I just swap these? No, that probably wouldn't work. So I'm running the problem of I'm starting using the word start and end implies that the coordinate circle has a 0 value here and a 1 value here, but in reality it's a 0 in the middle, and as you get further away the numbers get higher. So let me think, what can we do to fix that? We could either flip the things, we could flip the note progress probably. So this is all fine and good. What if we just put a negative in front of this? Would that flip the note around? Let's give it a try. I think it flipped it, but it also moved the timing of it. Since we made it negative, it basically moved it from 0 to 1 to -1 to 0, which basically moved it 1 unit. It did flip it, but so next what we would need to do is we need to add 1 to it. We might need to change this value that we add to it based off the length of the note, but we'll have to actually let's try making our note, instead of 1, let's make it 2 in length. Let's give that a try. Honestly, I think that works. So you can see it starts here. Let me load up the script so we can see it. So it starts at 0 to 0.4. And then ends at 2 to 0.4, which doesn't feel... Wait, that doesn't feel right. So it is the right order, but I feel like the values are wrong. So 0, I think that one is correct. To 0.4, that feels a little too big for 0.4. Or 0.04, I mean, sorry. Let's try making that 0.2 again, and giving it a try with an even length line, basically. Okay. I'm not quite sure why it's going down. Okay, so we are starting, I think that's 0.2 around. Yeah, so we are starting that correct, but it is going the wrong direction for the second set of coordinates. Yeah, so the first, so this line right here, let me load up snipping tool so I can draw on it. Yeah, so this, let me change the pen to something we can see. Actually, custom. Yeah, so this line right here is C0. That looks like a 6. So that's C0, I believe. And this is, wait, is it called C0? Yeah, so C0 and C1. So you can see it's 0 and 0.2. So I believe that's going this way coordinate wise. And then the second one is supposed to be 0.2 and 0.4. So the second one should be going up, but in reality it goes the other direction. You can see it ends at 0.0 or at 0. Let me load up the snipping tool again. You can see this part, it gets to 0, which makes sense because this is 0.2 width all the way around, but it's also going the wrong direction. I'm not quite sure why. Maybe we need to subtract this right here. Let's give that a try. I wish the stop button would show up so I don't have to like close the window itself. Okay, there. So now it's starting at 0.0 and 0.2. As you can see, starting at 0.0 and then 0.2. So that's C0 and C1 as it goes out. Okay, I think that's a lot better now. And you could see the, since you could see here that it is a linear type of motion that we're doing, since it is, we're using the LERP, which stands for linear interpolation. So it's a straight line, it's not like curved. But you can see due to the curvature of a polar pattern, it is giving us that curvature, which does actually look a bit like the game. So I believe we got that right. Let's now experiment fixing, it was having trouble going all the way around. So let's make sure that the circle degrees, let's see if this can go to 1. So I'm gonna give this a 0.8. This is not like more than all the way around, but it goes to the extent. Yeah, so you can see it is cutting off here, which is a problem. So let's see what it's starting from. Okay, so it starts from that same. I believe it is working except for it's cutting off at that axis. I don't know why. So what color was it cutting off to? Yeah, it was cutting off to this output. So it's not, this is returning false. I'm not too sure why. Let's see, polar chords less than 0.5. So it might have something to do with our adding the 0.5 that we need to figure out. Is less than 0.5. Wait, have we been not using the... Oh, plus width. Can we do negative values in here to see if it can go the other direction too? Let's give that a try. So I basically changed the extent of one edge to be below. Yeah, so now that, so you can see that edge starts at negative 0.5, so halfway around the other side of the circle and goes to 2. So yeah, going that direction does work. Let's give a try of going more than negative 0.5, so negative 0.7. Let's give that a try. Yeah, you could see it does cut off there, which is odd. It looks like it is working fine except for the cutoff, which it should not be cutting off because we're using, maybe this 0.5 is messing with it somehow. think it has to do with this 0.5, but I can't remember how I did it before that led this 0.5 to be not a problem. Technically, we could shrink the 0.5 to be a lower number, but that wouldn't solve our issue. We might need to do this fraction right here after we do that addition, maybe. I wish I would have copied my code I had before. I think it's on a different computer altogether. So, let's see. So we are adding 0.5 to it here. Wait, this should fix that issue. Adding or subtracting the start extent. Do we need to account for the start extent in here? No, because it is part of this. So let's just run through it with a sample value. So let's just say we are, so this value, so 0.8. 0.8 goes in here, it gets converted to polar coordinates, and gets added 0.5 to. So that would already cut it off there, I think. Unless this fraction right here would do it, would be fine. I might not be able to use this 0.5 here. Let's try putting 0 here, and then adding the 0.5 to that. Yeah, because I can't remember if I used. Okay, now it's reversed. Let's try subtracting 0.5 then. Okay. So we're going to 1 over here. This negative value is no longer working. Let's try changing that to a 0. And making this go slightly beyond, so let's say 1.1 should be enough for us to see. Let's give that a try. Yeah, it looks like it's still getting cut off. I'm not quite sure why, because we are adding. Do we need to add it before we do anything else? So polar chords is being referenced here with the note progress, but that's the Y. We're only influencing the X when we're doing that rotation. So that wouldn't be the problem. We're subtracting the start extent. I feel like it's getting cut off in this somehow. Let's try removing this 0.5 for now. 0, 0. Let's change that to 0. I know that's going to break our smoothing, but I want to see if this is part of the problem. No. Okay. Let's actually try. I don't know if that probably wouldn't do anything. Kind of just throwing things out there for now before we get too deep into troubleshooting, just to see if something works. Okay, this is kind of duplicating it across the Y, but not the X really. It's still cutting off at the X. Let's remove that fraction. change this back to 0.5. Actually, I am subtracting. Oh, I see. So I am subtracting 0.5 to both U and V right here. And now that has nothing to do with this. Never mind. Because this is just centering the previous coordinate system before we convert it to polar. So this 0.5 has nothing to do with it. So we're doing 0.5 here. Okay, so I think I see something. We might need to do what I was thinking originally and calculate that center point line, as you can see here, because we're only able to go half of the way. I don't know why this is not working quite exactly. So let's do center equals start extent plus end extent in parentheses, and then divide by 2, so we get the average. There might be an average function in the shader, but I'm not too sure about that. I'm gonna give that a try. So center, that's gonna give us the average of these, which is the center line. We're going to center if x is less than, let's just put in a fake value. This is center, this is changing the coordinate system altogether. So we can do negative 0.1 and actually let's just do it for real. So this edge would be the end extent. So we're gonna do polar chords, actually center minus end extent, or is it the other way around? The center should be less than the end extent, so end extent center. And then for this side, instead of this 0.1, we're going to do center minus start extent. I've probably messed everything up by now. It's outputting nothing now. Okay, so we are, I can't remember if this was a negative before. I'll try changing it to a negative. Actually, that needs to be nothing, a 0, I think, because we're handling, actually no, yeah, 0.5 like that. Yeah, I think 0.5 like that's fine. And then polar coordinates dot x minus equals the center. So that would be okay. If the center is greater than center dot start extent, or center minus start extent. Actually, I don't know. Let's just try that basic thing. If it is greater than negative 0.1, and if it is less than 0.1, let's just give that a try. See if it's rotating around. Okay, so basically what we're doing, we're using the average center of these for this. I feel like what I had before was closer to right though, but we're doing, we're making a 0.2 width line, since it is negative 0.1 to 0.1. We're doing that line around where the center is. You can see it's still cutting off because this last extent has 1.1. Okay, so I think I'm gonna try to go back closer to what I had before, because I feel like that was right. So we got the extent, got the center. I'm gonna remove the, actually I just comment it out for now because I'm not too sure. And this should be start extent. The polar chords.x is 0.5, negative 0.5 plus width. Okay, let's see if that brings us back to where we were. Yeah, I think that brings us back to where we were. We're starting at coordinates 0 to negative, or 0 to 0.2. And we're ending beyond the realm of this thing, which shouldn't be a problem because the whole reason I did the adding to the coordinate system rather than just going around is to fix this problem. But for some reason, the coordinate system is still limiting it. So I'm trying to figure out if it's a limitation of adding in here or not. Let's see, so this, how about let's just view our polar chords. Polar chords.x. Let's just view what that looks like for now. So I'm gonna close that and restart it. And I want to see how it cuts off. Okay. So it is, let's move it out a little bit. Yeah. And then as we go in, it kind of cuts off to there. I'm not sure why it's not just adding to it. Does this 0.5 need to be out of there or something? Yeah, it should be a minus because we are subtracting here, and this minus will make it an add. Because we were adding it before, I think. Is this any different? Actually, it might need to be a plus there. It's like getting locked on that edge. Not sure why, because when we run it through this polar coordinate, it subtracts that angle. I think we need to troubleshoot it more on the terms of dealing with our polar coordinate system first. So polar chords, let's try viewing what it looks like up here. So I'm going to close that. So this would be the most raw polar coordinate system coming out of our function. So you can see it's 0 there, and it gets to 1 here. That's as we expect. The next time polar coordinates references or changed is what we saw down here. Let's try commenting this out for now. Actually, instead of commenting it out, let's put this return above it, and then x plus equals polar coords.y. This should give us a spiral. Let's multiply this by 2 to make sure it goes around multiple times. Okay, so you could see it is... Oh. Yeah, you can see, this is what I was talking about a little bit earlier. How the functions, or these values right here, the compiler knows that I shortcutted with this return. It's never going to get to a point where it reads the note progress values, or note start progress. Well, it actually did something even smarter. It knew that I was not even referencing these values with my return, so it didn't even include them even though they were above what I did. So you could see it threw an error because of that. I'm not sure if there's a better way than to just comment these out for now. Let's give that a try. So now we're viewing... Okay, I'm not sure. Why it's locking into that. Let's try subtracting first, because that's probably more what I actually need to do. Why is it locking in? What happens if I put this in a fraction like we did before? It shouldn't need that because I put the whole x, yeah, that wouldn't do anything. Because you could see right here, I put a fraction in here. Maybe this fraction's actually causing errors, or not errors, but problems. Let me create a two-polar 2 where we remove this fraction, and we'll try using that and see if that does anything different. I doubt it would be any better. Yeah, that didn't really do much. Let's remove that. Okay, let's see. I wish it was easier to debug shader code. I mean, I could install that one NVIDIA shader debug thing, but okay. So this polar grid, let's see. So we're adding. Let's just try subtracting. Oh, I think I see what I might need to do. No, let's see. Let's try subtracting 0.2 and see if it cuts off the edge of it still. Okay, so that might be my problem. I'm subtracting the values from it, but I'm not actually changing the angle somehow. So when I go up here and do the angle offset, that should work though. Let's try 0.2 up here instead. Yeah, so that does properly rotate it. Okay, I'm just gonna do something a little lazy and do polar coords 2. instead of this being rotated, I'm going to do polar chords dot y divided by 2, just to give it a simple value so it can change over the y coordinate. Okay, so yeah, it is curling out. Let's change this, instead of divide by 2, multiply 2, so it can go around multiple times. Okay, so we're not having that clipping issue when we do this. It's making me wonder if we need to make polar coordinate systems multiple times. But that wouldn't make any sense though. Okay, so I think what we need to do, we need to remove this from here. So we have our input.uv minus equals, and then we're going to, we need to find the, let's put this in here. Oops. Yeah, so we remove that from here. So the input.uv, so the beginning coordinate system is moved to the center, and then we do this to it. So I think what we need to do, I kind of forgot what I was doing. So we need to simplify this, so this polar chords is being created afterwards, after we calculate all this. The only time it's being referenced is here, in which we basically would just need to get a distance to the center. I can't remember if you could just subtract. There's a function in the shaders that's kind of, let's see, distance. Yeah, so there's a shader, I'm just gonna play around with it till it works. So I basically need to find out the distance it is from 0, 0. I guess that would be Pythagorean theorem technically. Let's think about this. So we got, I'm basically creating the polar coordinate system part of it. I'm creating the y coordinate. I don't want to do all the calculations for the polar grid thing twice. So that's why I'm doing it like this. So we've got our point. We go out. This is our grid. Let's see. So we were, actually, let's see. Trying to, it's hard to keep all this in my mind. Yeah, so we need to find the distance. So right now we're on a coordinate system that looks like this. This is before we go into the coordinate, or the polar grid system. We need to get this point's location. So we need to do this line, so it's a triangle there. So it is basically just Pythagorean theorem. So x squared plus y squared square root, I think, right? I think that's right. If I remember the Pythagorean theorem. So if the x value is 1 to the power of 2, and then plus, let's say 3 to the power of 2, and then square root of that. I think that's right, yeah. So that should give us, I think there's a built-in function for this, but I can't quite remember it at the moment. And this will be simpler anyway than doing what we were planning on doing. So I'm going to implement that now. So this is to keep us from having to do the polar coordinate math twice, because as you could see, is to go through arctangent and do all this extra math right here, and it'll simplify the shaders. Technically, the performance impact from doing this probably isn't much on a modern system, but it's kind of messy code if you just keep doing it over and over again. So there's a square root function, okay. Hopefully this is right. To the power. Okay, plus. Okay, so this is just me doing to the power of 2. I'm just multiplying it by itself. And the square root of that. So let's actually just return center distance for now. Let's give that a try, and that should give us a thing similar to not quite sure. What are some of the... Let me see if I can find a list of functions for... So it's the vector length, HLSL. Oh, it's just literally length. I wish I would know that. Length of input.uv. I think that should give me the length. Let's give that a try. I'm gonna run it real quick after I quit that. I'm not sure why it's doing that kind of pattern. Let me try putting it above here. And shortcutting it a little bit. So this is not even using the polar system. I guess I used a length up here. Okay, there we go. So center distance is proper there. Yeah, so it is actually doing that same exact thing on the polar. I just do not need to calculate this part. Yeah, see, it's this Y chord. I guess I could have just went up in here and looked at that. So that is properly working there. Okay, so let's see. So we got our length. We don't need to return this anymore. This polar coordinate system can go down here. You can see it's being called for here, but this value, polar coords.y, is the same as what center distance is. So now we can move this down here. Instead of doing a polar coordinates 2, we can move this into here. Return polar coordinates.x, and then center distance for here. Okay, let's give that a try. Okay, there. That looks a lot closer to what I want. Let's uncomment out these values now, because it is relying on these values, and we can move them around, I believe. Yeah. Okay, that looks a lot better. You can see now it's not clipping anymore onto any particular edge, and it's not like cutting it off. Okay, let's try, instead of returning polar coords.x, let's try returning what we were returning before. And take a look and see. I think that actually worked. Okay, let's try making these values a bit more extreme. So we're going to go from 0 and 0.1, and we're going to go all the way up to 5 and 5.1. So this is going to be a 0.1 with object. We're going to give this a 3 value of length, so it's 3 screen lengths wide in terms of timing. Yeah, so I'm going to back it up. Okay, so you can see it starts here at, I know this is an extreme example, but it's worth testing these edge cases to make sure that we got the system right. So let me pull up the shader code real quick. So it's going from, you can see C0 is here, and C2, or I said C0, I should have labeled that 0 and 1, but C1 and C2, these are these first 2 points, so that makes sense, 0 and 0.1. And it goes around for 3 screen lengths. You can see here it ends at 5 and 5.1, which if you do modulus on that modulus 1, that would be 0 and 0.1. So that, I think that's correct. So I think we got this down. We just got to get the shading of it fine. I do want to try a few more things first. So we're going to start by having this start at 0.4, 0.6. And we're going to have it go to 0 and 1, I think. Let's give that a try. So this is kind of expanding from a singular point, if I did it correctly. Actually, let me lower the length of this note to 1 so we can get a better look at the whole shape. Okay, so it's starting really small. And for some reason, that 0 is not right. Okay, so this start seems fine. So it's 0.4 and 0.6. So that, let me write on it here. So this is the 0.4. Let me get my stylus. Okay. Oops. I think I closed the window. Let me load that up again. Then we need the shader open. Sure, whatever. And then, okay. So we got 0.4 and we got our 0.6. So those make sense. What I'm not so sure about is when we extend it outwards, it is implying that this point right here is 0, which is correct, but it's also implying that this is 1, which is totally not right. Let's try giving that a 2 and closing that and restarting and see if it actually goes all the way around. That's weird. It has this initial, let me write on that real quick. It's got this initial edge you can see right here, but it also has this looking edge. I'm not quite sure what that's all about. You can see when this edge is fully touching, that edge is not. Okay, let's try basic shapes again to see if we can find the root of this problem. I'm going to start at 0, 0 and go to 0, 1. This should start. Okay. For some reason, it is doing that completely wrong. See how it's not a solid edge? And it's not going all the way around. That's so weird. So I will say it is starting at 0, 0. That is correct. But the final point is not. Am I still using width? Yeah. Okay. So end extent is only used for width. It still needs to be there though. Okay. So I know the width is supposedly correct. I feel like when I've been playing around with making this before, I've had a similar issue to this. You can see it starts right, and then I guess that is right, except for the fact that it's only going halfway around the circle. I am still not exactly sure why it's doing that. the start of it is right, and that curve that we saw is accurate. So like as you could see, it curves like this, but for some reason it's not going all the way around the circle. It's getting cut off, I believe, which I guess is the error we were having, or the problem we were having before. Turn polar chords. Let's see if that would, let's see if it lets me convert a float to. No, it doesn't. .x. Because it's implying that there's a cut edge still. Yeah, it's not adding the start extent. Oh, well, the starting extent is 0 the whole time. Okay, I see why. I think I see a little bit why this problem's happening, because it is hitting the extent. So we do need this center thing still. Because we need to be able to expand from both sides, otherwise we will hit the edge, which is what we're currently doing. Since we're changing it by 0.5, we have 0.5 of the circle of range. So with the center, we need to subtract center. What am I doing here? Oh, okay. So this 0.5. Plus. So if the value is greater than, so if we're beyond it, if we are beyond, so we add 0.5 because we have 0.5 here, and then we have center. So let's do, this is the start, so start extent, actually center minus start extent, and end extent minus center. Maybe. I might be overthinking it and causing it to be not correct. Oh, I'm still viewing the wrong thing. Let's give that a try. Okay, let's think about this a little more. So the center, basically what we're doing, we have our polar coordinates. We've moved it. Here, let me draw it a little bit. So we've got our standard grid where it goes around like this. Let me just draw it like that. What we've done is we've changed that original line to be this way. And then we have, so we added 0.5. I know it says minus 0.5 here, so let's see. Center minus 0.5. Okay, so we subtracted 0.5, which actually moves it counterclockwise, I think. So that's the 0.5. And then let's see, we center minus that. So we're adding the center to it and subtracting that 0.5. Oh wait, no, I was thinking wrong. Where's my notes? There. So actually this arrow is wrong. Since we're subtracting 0.5, the line will go there, but it's going from this side. Wow, I can't draw. Yes, the line is going from this side right here. Goes from 0 to negative 0.5, and then we add, when we do our math down in here, we add this 0.5 right here. So that brings us back to the center, wherever my notes are. That brings us back to the center line. We also, when we're doing this change right here, we are doing center minus 0.5. So we're adding the center to it. So we're bringing, so let's just say the center is 0.1 the whole time. So we're bringing it to that. And then when we do our math down there, we add 0.5, so the center gets moved. So this line right here is our new value. And then we want to output the value if the value is greater than center, greater than the distance between the center and, yeah, so if it is less than, okay, let me just write this whole if statement again. So I'm gonna write in pseudocode, let's see, less than 0.5 plus extent or center. So this would be the end extent, I think. Yeah, so end extent minus center. End extent minus center should give us this range that I technically have already labeled. So yeah, so the end extent is this, you subtract center. So the center is at 0 theoretically at this point. So we subtract that. Wait, do we? We could give it a try. So what I'm doing here, it's greater than center and start. I think I'm already doing that. Except not the 0.5. If it is less than 0.5 plus end extent minus center, I don't need this width because the width is handled with this end extent minus center. Okay, that's still not working. Okay. I believe this part is right, at least. What about this side? So if the coordinates is 0.5, this needs to be a minus. That's probably it. Let's give that a try. Okay, let's see. Honestly, I think that's about right. It's getting to its place too fast, though. Oh, I know, that's because it's a 2. Oh, that makes sense. That's obvious. No, I think that's honestly it. So you can see it starts at 0, 0. So this tiny point, I have it C1 and C2 are 0. So you could see this tiny point, which would normally be like a flat line, well, a curved line following the circle. That's the start. And it goes all the way out to be 0 to 1. So let's give this a try. 0.2 to 1.2. So we're going to change the point where it collides at the end to be 0.2 further into the circle. Let's give that a try. So it still should start. You can see the point right there. It still starts at 0, 0. Then it goes out and then it ends at 0.2, 1.2. I think that's actually perfect. Let me think if I can do that experiment I was going to do before. I'm going to make it a little thinner to start, so 0.45, 0.55. I'm going to add the zeros for style. And then it's going to go to 0, 1. This is going to hopefully get it to start on one side and then fill up the whole circle. Yep, so we start this small area, so we got 0.45 to 0.55. It grows out to the entire circle at the 0, 1 mark, which is that. See, I think I figured it out. Let's just go through and make sure there's nothing we don't need. So we don't need that. recalculate that. Now, when we're doing the actual one with the actual, like, I think it's smooth step that you would do for it, we wouldn't be doing this like exact like less than or equals kind of thing, but I think I'll leave it for now. One thing I do want to play around with is making it transparent. These all have a value of 1. If I give this a value of 0, if I give all of these a value of 0, and then I make my game like blue, cornflower blue or whatever, I want to see if I can get these to have an alpha channel so I can, okay, there we go. Yeah, that works. So now the note goes around and it does that. Okay. So that's perfect. I'm going to change the shape to be something a little more common that we would actually see in the game. So we're going to go 0, 0.2, and 0.1, 0.3. Let's give that a try so it looks a little more normal. Yeah, so that's more similar to something you'd see in an actual game. Let me pull up my image of it. Yeah, so you could see we got the vanishing point as they have here. One thing we are lacking though is the coloring. You could see as it gets closer to the outer edge of the circle, actually to the beginning of it, it looks like it's not based off of that. It looks like it's based off of proximity to the end, because you could see on this one it gets dark by the end, this one it gets dark by the end each time, this one it gets dark by here. So I think it is based off of its progress that controls its brightness. So it starts at its full value and then gets darker, I think. So let's give that a try. So I'm going to actually use this snipping color picker. Wait, I can't remember how to use this. Oh, color pick from page there. So let's get this yellow, roughly at least. Color picker. So this is, I wish it would give me it in, I mean, I could use this. And that's hue, saturation. I just need to divide all of these by 255 because it's a 256 base system and I need to convert it to a 1 base system. So actually I'm just going to make a spreadsheet real quick to do that easily so I don't have to do it on my calculator. Okay, so I'm just going to input in the color values, which is 211, 1. I'm going to do snipping tool so I can keep that because that window keeps disappearing. Color picker. Okay, there we go. So we've got the color 211, 197, and 96. Okay, so then in this column we will do equals that divided by 255. Okay, so now I got those values that I need for the color. I think I could do a start and end color, but for now I'm just going to do a darkening value. I'm going to label them up here because in the game you would be able to change the color of these. And also, when you're playing, I don't know if you noticed on this right here. Oh, actually, yeah, this right here. Let me not zoom in. The one on the left, you can see when you miss the note, it's like this solid, like grayish yellow color kind of. So we'll need to interact with the color through script. So that's why I'm putting it up in this top area. So float for color equals, I'll just give it that starting value of what we came up with, point. Actually, it'd be easier to copy it probably. And then we'll give it an alpha value of 0.8 for now. We might play around with that. Darkening value, we'll make it darken by 0.3. 0.3. Yeah, so now I think for now I'm just gonna leave this, since for the sake of time with the stream, so I'm not like working on this hold note the entire time. I'm going to leave this as is now, but I'm gonna set my output color to start as this color right here. Oops. I should probably name it better. Note color, because color might be a keyword already in this language. I'm not sure. Actually, it's probably capital C color. Anyway, we got our note color, and then we would want to lerp this, because let's see, note color minus darkening value, note progress. Okay, so this basically what it's doing, we're taking the initial note color and the note color minus the darkening value. So that's going to, actually let me make sure that this doesn't go into negative values. We're going to clamp that. Actually, not clamp. We're going to max it with 0.0. So what this is going to do, if this value is less than 0, then 0.0 will be the maximum value in this set. So it's basically making sure that it's always outputting a 0 or higher, so we don't get any weird shading. Probably not something we need to worry about. That was probably something that is in here. And instead of minus, actually let's do multiplication. We wouldn't even need this max with that too, because multiplication works that way. So let's make it 0.8 of the brightness that it is originally. Okay, so now that should work. And this actually needs to be within the note definition. So in here, this, like that. Okay, this can probably be simplified. But for now, I'm just going to test it out and see how the note looks. Remember, we have that weird blue color in the background, so it might discolor it slightly because the alpha channel is 0.8, I believe. Let's see. Yeah, 0.8. Let's give that a try. Yeah, so you can see it is bright there. And it seems to like fade lighter. Let's try setting this to... Actually, I think I know what I need to do. So what it's doing right now is we're multiplying the entire note color, which includes the alpha channel. I don't know if we can do this. Float for note color dot W. I think that works. So what I'm doing, I'm taking the X, Y, and Z values and then multiplying it by the darkening value. And then I'm also adding back in the alpha channel of what it was previously and creating a new float for. So let me close that and start again. Yeah, that looks a little better. You can see it sort of darkens as it gets closer to the center. I think we can make it even darker than that. So let's try 0.4. That might be a little too much, but it'll give us an idea on how it looks. Yeah, in the future, we might want to give it 2 colors. So let's actually do that so it looks a little more accurate. Because darkening, I don't think it's doing darkening exactly that way. So let's get a sample of the color in the back. It's more of an orangish color, actually. Yeah, which is why it probably didn't look too accurate. Because we were just darkening it, getting it closer to black rather than getting it closer to orange. I wish this menu didn't disappear every few seconds. Color picker, there we go. I need this. Fine, I'll just copy it and put that into my spreadsheet and then just deal with it after. So we got 211, which is the same, 197, and then, wait, that's the same value. There we go. So we got 206, 142, and 25. Let me extend this function across those. Okay. So now I'm going to copy in these new values. Which will give us this. And instead of doing this darkening thing right here with this darkening value, we'll just change this to note color 2. So it will just go between those 2 colors. And that will give us the effect we're looking for, I believe. I don't know why I have 2 of these open. I think I accidentally closed my Solution Explorer. There we go. I gotta redock that on this window. Okay, let's give that a try. See if the colors look a little more accurate. Yeah, that looks a lot better. The bright yellow, I'm not sure if that looks right at the start. Like this bright yellow here. Let's take a look. It's close enough. We can modify it later since it is just parameters into the function. And that will be influenced through script probably more than it would be through the other stuff. So yeah, I think we got this note down. We just got to get the start head for it, which is going to be made out of the standard note, but just changed in color. So I think that might be a good place to start next. One thing I've noticed, you can see this edge, it lines up with that. Same with this, but you could see a little, oh, that's the end from the previous note you could see sticking out there. Let's see. But some of them you can't see the, I guess it starts a little bit forward of that. Yeah, you can see it doesn't start after this touch note start. It starts a little bit before. Okay. Yeah, we basically need to get the effect of this initial, basically make the initial note, I guess. Let's try layering multiple of these on top of each other now. So I'm gonna try going, I'm not sure if this will work very well. I'm gonna create a new sprite batch because in order to do different effects, you have to do that way, I think. Let's see. Hold note 2. hold note 2. This will be like more automated when in the actual thing, but for now this will get the idea across. Okay, so we got those in here. One other thing, we would want it to not be overlapping like completely. So we'll want to change the corners value, which might be a little tricky. I don't know how to input in a float 4 variable. Let's just give it a try and see what happens. So we got hold note 2 dot parameters. So corners, that's what it's called. Dot set value. Is there a vector 4 in here? Oh, I guess there is. So we'll create a new vector 4 of point. So what are we doing currently? So 0 to 0.2. So let's make it overlap 0.1. 0 to point. Is it 0.1 f? 3 point. Not 3.3. 0.4. And we're gonna do 0.3, and then 0.5. That should be fine. Hopefully that works. Let's give it a try and see if we can see both notes on the screen. I only think I see one of the notes. Oh, we're giving the same effect to both notes. So I'll give this effect to the second one. And it felt like we were modifying. No, I guess we are doing the right one. Let's see how that works. It feels like it's applying this to both of them. I don't know if it's doing something where it just guesses that I don't want to. Let's copy this. Corners for this one. So we like hard coded in this side. Yeah, I'm not too sure. It could be doing both actually, but just overlapping them. And the way it's mixing them isn't. Yeah, let's change that. So we'll change the note color. Note color of this to be like perfectly white at the beginning, and then it will still go into that yellow that we have before because we're just affecting note color originally. Is it not drawing this one? Because I'm only seeing the one that's like perfectly white at the beginning, and then it transitions to that orange color. Not sure why hold note 1 is not. If I comment out this drawing of hold note 2, does it still? For some reason it's affecting this effect as well. I am not sure why. When I'm changing the parameters of hold note 2, I don't know, I think that's a issue with this that we could figure out later, since today we're mostly working on shaders, I think. So I guess we can move on for now to, I guess, the standard note. So I'm going to remove all this stuff about hold note 2. Okay, so now if we run it again, we should be able to see just the hold note 1 that we have. Yeah, there we go. So there's hold note 1. Yeah, and I don't think the YouTube stream would show it very well, but you can sort of see a pixel outline on the edge of this. This is because we're not doing that that thing I was saying. I was instead of doing if it is less than or if it is greater than, we need to like smoothly change the color between them. That's something that we'll probably work on later. For now, I want to move on to the note so we can actually get something more. Actually, instead of the note, it's not a game element necessarily, but this like outer ring might be good. Although it's probably a good idea for us to actually have one of the notes. So let's inspect this note real quick. So there's a cap on each end unless it is a full circle note. And you can see it's darkened from the center here and it's darkened from this edge here. So I have done this with like programming in gradients before, but I think doing a texture will make it potentially easier. So I'm gonna try with GIMP. I'm going to create a width. Technically we could do a width of 1, but I would like to be able to actually see what I'm doing. So I'm going to do a width of 100 and a height of 500, I guess. Actually, let me change that to be less. So we have let me put this on screen. I kind of want to find a texture size that fits with the size of these caps. Okay, so we need to do a gradient. The first one will be center base, so this needs to be at 150. Where's just the standard select tool? I'll just rely on the mouse position guide to be correct. Okay, so we're going to be doing a gradient from this edge. I'm just going to make borders around it so I can get the gradient aligned. We want this to be a white to black gradient, I think. Wait, let's take a look. Actually, a black to white, probably. Or something. So let's see, let's take a closer look at the note. So it is, we're gonna do this blue edge first, probably. I wish I had a higher resolution picture of this note, these notes, but well, here's a close-up cap. So you can see it's more evenly distributed of the gradient than the other one, I think. It might be still leaning more to the top end still. So I guess we could try that roughly around here. Let's give this a linear, and then we'll do 2 of them. We'll do another one on this layer. And we will erase. Is this the box select? I guess rectangle select is the same as box. We'll delete this from here. There we go. I think that will give us kind of the effect we're looking for. And we can scale the contrast of this inside the shader. This is kind of just a starting point. And we need it to be black and white so that we can color it whatever way we want, basically. So let me export that. Note gradient. Yeah, so note gradient. Export, that's fine. Let me go back to Visual Studio and open up content, and then I'll add that image to it. Add existing item, downloads, note gradient. Save and then build. Okay, and then I'm also going to create a new shader called let's see, what was it called on here? It was called a touch note, I believe. Yeah, so touch note. So I'm going to create, it's going to be, I wish I would have named my hold note with a capital now. I wonder if it will let me change it. Probably not. There. I made this touch note. I'm gonna do sort of what I did before, removing the vertex shader, since we're only really working in pixel shaders for this. What's wrong? Comment in a line expected. Oh, there's no semicolon for that. Okay. So now we got our basic touch note, and then we'll swap over. I'm going to comment out this, remove that. Instead of this, we're going to add a touch note effect. And we're going to duplicate this touch note equals effect of the name touch note. And we're going to remove all the hold note stuff. We're going to change the effect to touch note, and on touch note, to just make sure everything's working, I'm just going to return a float for 1111, and we'll see if I build, we should get a white screen like we did originally. Touch note. Content file was not found. Let me rebuild, maybe. For some reason I don't see it in content. Let me add existing item and then add it. For some reason it didn't get added. Let's try that again. Okay, there we go. So we got our white screen again as we expected. This is kind of a fresh start to do it. And I know that we will need this polar grid again, since practically everything will need this polar grid, since we are working in the game works in a polar system to curve everything, I would believe. The difference with the touch note, I'm not sure exactly how we want to do it, because we could scale everything and do all that and have it move it around and stuff. I think having a progress value would be the easiest, because we can scale. Basically what it would do with these touch notes is it just scales up the image of the note as it goes from the back to the front. But I think what I'm going to do is add a progress value in the same way that we did with these hold notes. So yeah, let's see. Where's my script? There it is. Okay, so we got our polar grid the same way we had it before. Did we make any changes to it in here? No. Okay. So we're kind of going to be doing the same thing that we did before, except for instead of a long thing, it's a note. So since we are using a texture, we need to make sure our UV is scaled correctly. So I'm going to add this UV coordinate back in. I'm going to add a float progress equals 0 and float this is going to be width, I guess, equals, and this is going to be the amount of width it will be on the y coordinates. So I'd say 0.008 maybe, because it's from the center out to the edge. That might actually be a little too small. We can play around with it later. Actually, for now, I'll make it 0.1 because we'll need to be able to see it larger anyway to be able to test with it. And then similar to the hold note, we need to have extents for it. So on this, we called it corners. I guess it would be more accurate edges on this since it's like that. Float 2, we'll start it at 0. Now the question is, do we include the caps in that? And based off what I've seen, it doesn't look like it. You can see the grid, this line. Let me open snipping tool. There. So you can see this line is the edge of the note. These lines are like part of the background of the game. So I believe the cap is not included in that. So we don't need to do that. So we're gonna do 0 to 0.2, I guess. That should be fine for now. Let me remove that line. So these are the parameters that will interact with it. So actually we need to have we'll have a float. So we need to have parameter for the color. So we'll have color. Actually, we'll have note color 1. Actually, just note color. Float 4. Just a note color 2. Cap color 2. And also one thing I noticed when looking at these, they sort of have like a white-ish glow around them. I don't know if I can get it to be too visible. But around like the edges, there's like a white glow. Yeah, it's kind of hard to see in these images. So we'll have a edge glow parameter as well. Now let me get these color values. So we got this darker pink. I'm gonna put that in my spreadsheet. And then we've got this lighter pink. I'm gonna copy that. Okay. And then we've got the darker blue. Actually, I think I copied the wrong spot. Yeah, so we got this darker blue. And we've got the final one is this lighter blue. Okay, and then I'm just going to put these into the spreadsheet real quick so I can get the color values for them. Okay. So I got those colors, and we'll just make the glow color white. And for the simplicity of this project, we'll make it only on the edges. We'll make it only on the edges that are parallel with the x-axis. I know saying parallel is a little weird in this sense since the axis is curved. But parallel with the x-axis. The caps on the edges of the caps I think would be fine to leave without the glow and still get the effect across. So let's go back in here. I'm going to, I believe all of the notes have a 100%. Let's see. Dark. Cap color, dark. Yeah, so I believe they have a 100%, like the transparency, you can't see through them. So I'm just going to set the transparency for these to be 1. If we find that we need it, of course we can change it to whatever we need. So we got our, I hope I remember the order of these. I'm realizing I didn't label them very well. I think I labeled them well enough that I can do it now. So let's see. Dark blue actually has a 0 for that first value. We'll give it a 1. I messed up that one. There we go. So cap color. So the cap color is just like the bright version since we have cap color dark already. And we'll just make this edge glow just white basically. Okay. So we got the glowing. Okay. So first thing, we might need to like scale it might be useful to have a remap function, which a remap function is basically just a mix between a lerp and an inverse lerp, which you give it the input coordinates or the input values and then a 0 to 1, or like it basically sends it to the other thing. So the 0 to 1 output from the inverse lerp goes into the lerp, and then so you can basically remap a set of values to another set of values. So that might be useful for us to reposition things, so I think I'm gonna make that real quick. So we have our inverse lerp right here. I'm gonna add a remap function from 1 from 2 float 2 1 float 2 2 and float. You don't need a value since the 1, actually you do need a value, and the value of this is actually the, yeah, so that's the value between the ones. So the inputs kind of work kind of like the yeah, so it's a mix between them. So the remap, basically what we'll do is we'll return the lerp of, so this will map it out to these values, so 2 1 2 2, and then inverse lerp we will do from 1 from 2 value. Okay, I think that's all you need for a remap function. I don't know why they wouldn't just put these into the shading language to begin with, because they're used quite often, but I guess so. I have to have to program it. So the note, first we need to get the texture in. So I can't remember how to get a texture into this. I don't know if it is this color value. Actually, we will need to input in, this might have multiple textures. There's a lot of parameters for this. So we have a texture, note gradient, cap gradient. Okay, so we have these two textures. We have to make sure that we pass these values in when we run it. And I cannot remember how to sample the texture. Is it just texture.sample or something? Is it, so we got note gradient dot sampler. Oh, we have to create a sampler 2D. Actually, we don't need to create that up here, I don't think. Let me just see what you have to do online. You just do dot sample, mesh texture dot sample. Yeah, so you got the texture. So we got note gradient dot sample. And then we pass in the sampler. I don't know what that. Let me see if I can find an example for MonoGame. Here's let's see. This guide I'm seeing is mostly in C# instead of the shader. Wait, can you just pass in? I think I'll pull up my previous code. That make things easier. I hope Visual Studio doesn't kick me out of this project when I do. Okay, I can't even remember what this project was doing last. Let's just run it and see what happens. So this was I was playing around with the rainbow effect that happens whenever you hit, I think it's called R note. Yeah, so the rainbow effect here. I was trying to get that to work, but that's besides the point. I need to find how to sample the texture. Okay, so I do this, and I created a new sampler for each one. Okay, let me just paste that in under this then, I guess. So I use texture 2D here. And then I created a I think you put it in like that. Yeah, so you put it in like that, and then to get the color from it you do text 2D and then yeah, okay. So you pass in the coordinates, so let's make sure we can actually view that texture before we get started. I should really rename these. Note texture, and then I'm just gonna set these to 0. Actually, this should be a float 4, and then I'll return that instead. Return read value. Let's give that a try. Oops, I was clicking the start button on the wrong Visual Studio since I have the other one open now. Looks like it's still outputting white. Am I passing in? Oh, because I haven't passed in the texture for this yet. So the parameter of this is called note gradient and cap gradient. For right now, I'm only using the note texture, which relies on note gradient. So note gradient, I'll have to pass in the values for. So touch note dot parameters note gradient dot set value, and then we'll have to load in the gradient for that. So we'll create a new texture called note gradient, I guess, and we'll have to duplicate this, and then this one is called note gradient, and this is a texture 2D. I'm gonna move this up above to here and add a new line, so the texture 2Ds are together and the effects are together. And then I'll pass in note gradient into here. There, so now we're passing in the texture for note gradient into that. Let's see if that runs any differently. Apparently not. Okay. I am returning read value, but Let's see. If this was reading the value at 0, 0, it would be a black color instead of a white color. Let me see how I did it before. I guess I can drag this window out and show you. Let's see, so we're looking at the... Do I even have this effect used? Note effect? Well, here's the note gradient. So it's loading it as texture 2. I'm guessing you would just do it like this. Okay, not exactly sure what's wrong with this method. Let's see. Let's look at our game file. So we are loading the gradient first, and then we're loading the effect, and then we're loading, putting in the value. Oh, we're not using texture? No, that texture doesn't matter since we're not using it anyway. I'm wondering if it's not including these in the compilation for some reason. Then again, when I did this previously, I didn't need to do that. So this is what I did previously when I was playing around before the stream. Yeah, I did change it to 9_3 as the version. So I got, let's see, the note color, and I got darkening. So this area looks like I was doing like the gradient still. But what is this? Is this even being used? Texture position. I mean, I guess I can copy this and see if it's doing anything. So instead of that sprite sampler, we're going to use note texture as a sampler. And then instead of this, we're just going to replace that with the X value is 0 because we're only using part of this texture anyway. UV input .uv.y texture position. I mean, that's the same as what I just did, I think. It's still all white though. sure. It feels like the hardest parts that you get stuck in when programming shaders is always the most simple parts. Yeah. Is this texture 2D not working for some reason? Let's try simplifying it again. So read value. This outputs a float 4, and then we got note texture, which is the sampler, I think. Maybe we have to pass in this texture, the note gradient, into here, because it might be like forcing it to use that all white texture for some reason. I don't think that will change anything, but we can give it a try. Oh, there we go. I don't know why it's doing blue, because blue is our background color, and it's thinking that the black is opacity as well. I'm not sure. Okay, so at least we can read this now. I don't know why it's really requiring that. Let's see if we can actually get the other texture passed in. We'll make a... Actually, we don't even have another texture made. Let's do that later then. So either way, we got our note gradient to show up like this. So we are able to read that value with this. First, like we did before, we need to convert it to the polar system. And we'll want to expand it from the center as well, using that same system that we did before, so we avoid the cutoff issues that we were having before. And yeah, when it gets to a certain point, it's impossible to have the smooth edges for the caps when the caps are too close together. But the actual game wouldn't make the caps be that close together. If they're any closer, then it would just be a full circle. So that's another... Do we have cap size on here? So cap size. So that's going to be like the size of the caps on the side. So how long they are. We're going to start it out with 0.05 or something. So we're going to first, we're going to do the polar coordinates. So float to, did I name it that on here? Yeah, polar chords. I just want to keep a consistent enough naming scheme. Equals to polar. Then we're going to input in, and actually we'll have to do this in a similar way we did to the other one where we do the polar coordinates after doing some math, but we'll put it in here like this for now. And then the angle offset, we'll just do 0. And above this, we'll have to calculate. So we already have the left and right extent of the note, but we don't have the center yet. Float. What was all that? Center equals. So we've got edges. There's no average function, I guess. Edges.y plus edges.x. Divide by 2. Okay, so we got the center of the notes. I'm just going to change this to x and y because the order. Yeah, so we got the average of those, which would give us a center. We basically need to do the same kind of thing here. So we need to add the 0.5. Let's take a look at what we did over here. Yes, we did center minus 0.5. Center is not declared. Oh, note center. There we go. Okay. And then to get the, let's just try first creating something that shows the bounds of the note. So it doesn't even rely on this read value. So if we're gonna disable this return. Actually, we're going to swap it out for this one. So if so we have the progress, I think it's called. Yeah, so progress is how far it is away from the center. Basically, so a 0 would be in the center and a 1 would be at the edge. So we got, if the progress is, wait, so we need the polar chords dot y, since that's how far away it is from the center. If the polar chords dot y is less than progress, less than or equal, then to progress, and polar chords dot y is greater than or equal to progress minus the width of the note, basically. So I guess I called it width, so minus width, then return float for, we'll just make it white, I guess, because otherwise it will be returning this red color down here. Let's give that a try. It should make a circle for us. It does not like that. Object reference not set to. Let's just comment that out for now then. Okay, where is it running? Okay, I have way too many content managers open. Okay. Let's give it a try again. So we could see it's all running only white right now, which is not what it's supposed to do. Oh, I know. Because, well, one thing that's wrong, I don't know if this is the problem, but before we were doing this, or we moved the center, that's something that we would need to do again for this. So let me close that and see if that makes any difference. It will probably not fix our problem, but it's something we need to do eventually. Yeah, so it looks like it's still all red. So let's think about this. If it's less than... Oh, progress is 0, so that would explain it. So let's go make progress 0.5. So now it should be starting from the center of the range between the outer. Yeah, so now we have kind of a target, kind of. So this white range is the area that is the note. And for this, we'll probably definitely need to implement sign distance field to get these fuzzy edges to be, or not fuzzy, but like pixelated edges to be smoother. So let's think what we want to do first. So we have a note center. We'll rename this to note center X, because that's the center X value, I think. Yeah, note center Y. We need to have that value eventually. Because to do the sign distance field, we just calculate the width divided by 2 plus, or using that. I'm trying to think if I labeled these correctly, X and Y. So the Y is out. Yeah, so this is a X value, but it is, if you plotted it, it would be a line on the Y axis. So that's why I wasn't too sure, but I think that's fine naming. Let's see. So we got note center needs to be renamed. And for now, I'm going to do the same if statement, although in the future we do need to do it with the sign distance field kind of type thing. But I'm just trying to get this through this fast enough to get into this stream. I'm not sure when I would do the next stream. Probably try to do it on Saturdays, but I'm not too sure how my schedule will be. But yeah, I'm probably gonna stream for another like 30 minutes. See if I can get this note to a workable state. Okay, and then so we got this coordinates. We want to remap the X value if we want to use this texture properly. So let's make sure we can get the edges working too. So this if statement will return if it is within the bounds of the note. So we'll say and polar chords.x. And remember, we are adding, or we moved the x, let's see, polar chords, yeah, we moved it by this. So actually this isn't, yeah, so it's the same kind of story that we had with this right here, where we moved it to the other side, then we moved it slightly, and then when we're adding to it, we add 0.5 back, so it's in the correct spot. So that's kind of a similar story with this. Let's see. Less than progress is greater than progress. Yeah, so we want to know the width of the note. Note width equals edges dot y minus edges dot x. Okay. And the nice thing about notes, that we don't have this problem with notes compared to the hold notes, is you can't have a note that goes around more than 360 degrees. Yes. Yes, programming fun. I wish it would give me timestamps on... Oh, there we go. Toggle timestamps. Yeah. Yeah, my chat window wasn't really showing timestamps. Okay. So we got our width, and then we need to do if it is... So we need to add that 0.5 back to it. So polar chords.y plus is less than, or actually is greater than or equal to 0.5. So we're adding that 0.5 that we subtracted back here. And that's similar to what we did right here. Then we add the width on that side. And since the we have the center of the note, the width is the same on each side. And now that I think about it, these should be the same. We can go back and fix that later. Well, not fix, but change it to be simpler. Okay, so we got this, and then we, since this is greater than or equal to, we want it to be minus, and then we subtract the note width. Okay, yeah, so note width divide by 2. And also we have to keep in mind the caps. If this is going to be like a limiter kind of thing, the caps add, yeah, imagine timestamps. Yeah, the caps add a little bit of like space on each side. So we have the cap size variable. So this is, since this is splitting it in half, since we're doing it based off the distance to the center, we can just add cap size to this. I'm just going to put this in parentheses so I know that it works kind of with that. I technically don't need parentheses there probably, but it'll make it easier to read, sort of. And then we'll kind of copy this again, except for it's going to be inversed slightly. Instead of greater than equals, it's less than or equals. Instead of plus, it's minus. The cap size stays the same. The width divided by 2 stays the same, which I can change that into another variable up here, so I'm not doing those calculations twice. Let's take a look and see if this does anything correctly so far. Well, it's still a full circle, which is not necessarily correct. So the polar chords.y. Let's take a look at what our polar chords looks like. So we've got polar chords.x. We'll just see what the x coordinate looks like for now. Okay, so you can see we've added the note center and we've added the 0.5. So that's actually kind of similar to what this graph is showing. So that's this line right here. Yeah, you can kind of put it side by side. So we need to add that 0.5 back, which we're doing kind of here. Let's see, minus. I could try changing these to plus to see if it fixes it. It'd probably make it just all red though, or whatever color. Whatever color is the default color. It'd probably make the note not exist at all. Yeah, so now it's all red. Okay, let me change that back. Okay, so we got polar chords.y. If it is greater than 0.5 minus. Okay, so if it is greater than, if we think about it in terms of this, if it is greater than, so this 0.5 brings it to here, and then it subtracts that value, so it brings it back down a little bit. So I believe this is right. And then the next one, if it is less than 0.5 plus, I don't see how this is wrong. Because we already tested that this limits it to that. Let me set the progress to 0.7 or something a little bit higher, so it's a little bit bigger of a circle. Yeah, so let's just do a sample test. I'm gonna comment out this line, create a new one. Instead of doing all this, we're going to do and polar chords dot y, or actually dot x. Oh, that was the problem. I was doing the y coordinates instead of the x coordinates for these. Okay, let me close that window real quick and then try it again. There we go. Okay, so now you can see that it's supposedly supposed to be between 0 and 0.2. Doesn't look exactly like that. It looks like negative 0.1 to 0.5 or something. Unless it's rotated in a weird way. Let's change this 0.2 to be 0.1 so we could see what direction it's coming from, basically. Because I don't know which side is which, basically. Okay, so it is coming from this bottom side right here. The real question is, why is that below this when it's supposed to be 0? Let me set the cap size to be 0, just in case that's messing with my brain a little bit. This way the edges will be within the pink part of the note. Okay, there we go. So I think the cap size was just way too big. Let's set the cap size to 0.05 and see if that looks any better. It's still quite big. 0. And just add more zeros at this point. Okay, that looks more reasonable. So I think this is working. Let's make sure that we can do negative values. So let's do negative 0.2 to 4, because the good thing about this note is it's a lot simpler than the whole note in terms of the positions it can be in. Yeah, so I think this works. So I'm going to change this to 0 and 0.5 so we can get a wider scope of the size of it. Yeah, okay. So you can sort of see, I can't tell, I don't know if you can see it really in the stream, but it's going a little bit beyond the 180 degrees because of the caps. So that's what we want. So next, I think I'm going to be a little lazy, and for the caps, I'm going to, let me load up the image of it. For the caps, I'm just going to use that same texture, the same gradient texture, but just like, yeah, first we'll just start out by using the same gradient texture, but just change the color of it. So to find out the coordinates of this texture, we can do multiple things. We could either change the UV coordinates of the polar coordinates, so we can multiply the y through this remap. That's probably not the best because we might rely on this polar coordinates afterwards. So what I'm gonna do, we're gonna use, I think we're gonna still use the remap, but we're going to put it in an intermediate value. So it's gonna be like float gradient progress. And actually for this, we probably don't even need a remap. We could just use an inverse lerp, so I don't think we even need that remap anymore. I'm gonna leave it in just in case we do. So we've got gradient progress, inverse lerp. So we're going, and since when we read from this texture, it's from 0 to 1, the inverse lerp works perfect because it outputs a 0 to 1. So we're going to, the lowest value we would get, let's see, that would be, so this is all based off of the progress value and the width, I think. So the lowest value is progress, and the highest value is progress minus width. And then the value we're inputting in to test is polar coordinates.y, because that's how far it is away from the center. Okay, so gradient progress, and then we can move this read value below there, and then we're going to input in, we're going to create a new float2. So we're going to read, the x value is always going to be 0 because let me pull up the texture, because the x value, it's the same for any x value on the texture, so we can just use 0. And then gradient progress is just going to be that value from a 0 to 1. And since we are going from progress to progress minus width, progress is a higher value and this is a lower value, we might need to switch these. We can give it a try first. Let's give this, instead of this, we'll give it red value or read value. And see what it does. It should show our gradient. There we go. You can see our gradient, but it is reversed from what we want, because you can see the outer shine is on the outer part. We want the outer shine to be on the inner part. I'm gonna just try swapping these, see if that gives us the effect that we want. So that we have the lower number first and then the higher number second. Okay, yeah, that gives us the effect kind of that we want. Then you could see it is making a transparency to the blue background that we have. So we need to multiply the red value. I guess just the red value of the red, the red as in color value to the red as in reading value variable. We could use any color, but since all the colors in this, because white is 100% of red, green, and blue, and black is 0% of red, green, and blue, we can just use any of the colors for it. So we're going to use note color, and we're going to use a lerp for this. So we're going to do note color and note color dark. So this will go between the note color and the note color dark. And then for the value for it, we're going to do read value, I think. Or read value dot red. We might be able to do RGB from this, but that might lerp individual sections of this, which might be kind of cool effect, but we don't need to really get into that. So let's try this and see if it works. It should use the colors that we specified. Yeah, it looks like that worked. Except for its inverse of what we want. We want note color dark to be here, and note color. I think it's starting to come together in terms of how it looks. Let's take another shot at it. I'm not too sure about that. What's this like? line in it. Let's change the width right here to 1 and the progress to 1 so it fills up the whole space so we can get a bigger view of it. Okay, I'm not sure why it's that kind of color when it gets to the darkness. Let me see, this is the color I gave to it, I think. Let's just change it to let's remove this red so we get an actual, more accurate output. I don't know, either way it looks similar enough that we can play around with it to get the values that we want. And then, so we need to figure out the caps. So we can either do the caps with the same greater than thing, or we can do it with more like the sign distance field, which is what we need to move to. I need to figure out that, I think it's called a smooth step that I saw someone use. Actually, I think I might have an example of it in my other project. Let me pull that up real quick. Oh, smooth scale. Okay, let's see. Yeah, so this is the shader for that rounded rectangle thing. So this is just a sign distance field for a rounded rectangle. What we're using here is smooth scale. What is that? I can't remember what I did. Oh, there we go. Smooth scale times gradient color, smoothed alpha, smooth step. There we go. So this is what you can use for doing that. I'm gonna get a screen capture of that so I can remember it. So we should probably just work on turning this into a sign distance field sometime soon, but I probably need to stop streaming soon, so I'll probably do that at a later time. For now, I'll just get it working with the blue caps, I guess. And since it is a return statement, we don't need to put an else, because everything else would, it would return and exit out here. So instead of returning this for out here, we're going to cap color dark, cap color, and the read value is the same since we're using the same gradient. And for this, we're going to make sure the note is within the pink range. So what we're going to do is polar chords.x. And actually, I'm going to copy what we did up here because it's kind of similar, the type of math, except for we're going to remove the cap size. I don't need all these parentheses either. Let's take a look and see if that works. No, there are build errors. Let me see. Uses too many instruction slots. Okay, so we have to change the shader to a different version. Let's give that a try. Okay, there we go. It looks like the caps are on there. It's kind of hard to see with this blue background, which I probably should have thought through a little better. I'm going to change this to black again. Give that a save and retry that. And I'll scale the note down so we can see. Yeah, so it looks like we got those caps down on there. I'm going to change the width to 0.2, the progress to 0.9, or change the width to 0.07 actually, and this to 0.4. And then I'm going to go into this game and make it a little bigger so it might be a little easier to see. 800 pixels by 800. Okay, let's give that a try and see if that looks like an actual note. Yeah, the shading on the on that bright part is a little bit odd. I'll have to look into that. But in general, that's the general look. You could I don't know how well it is to see on stream still, but I might be able to demonstrate it if I get a screenshot of it and then zoom in. I'm just gonna put it on this slide. I don't know if you could see that very well with the jagged edges. That's because we're just doing an if statement, basically. If it is within that or not, and it creates this jagged edge, we need to switch to that smoothness, basically, which requires us to calculate the distance to the edge using signed distance fields. But I think that's about all the time we have for today's stream. So I think I'll end with trying to put draw a note and a thing on stream or on the screen at once. Hold note. I'm gonna draw the hold note first because white square, because I think it draws in order and it would overlap the other one. Let me uncomment out my note settings, see if it works off the bat. Otherwise I can add things back. Okay, let me set the size of it so it actually looks like an actual note. So I'm gonna go to my hold note, 0 to 0.2, that's fine. I'm going to change it to 0.2 or 0.1 to 0.3, yeah, that's good too. And I'm also going to change the length of it in my C# right here to 0.5 so we can see the whole note, so we can get a little good view of what we've done. I'm going to change my touch note to be thinner, so 0.4 is probably fine. The progress, I'll give it progress of 1, and I'll set this to 0.2 so it matches our hold note. I'm just trying to make it look like the hold note comes out of it, sort of. Okay, the cap size is a little too big for that small width. Let me change it to 0.6 and 0.4. And these are all like settings we can play with to make it look a little bit more like the actual game. And right now it's going to the edge of that instead of the edge of the cap. I don't know what the proper one is, what it should look like. Yeah, so it looks like it does go to the edge of the cap. So let me modify that a bit. That's the wrong window. I have too many windows open now. I think it's this. Okay, so we're gonna take this cap size into account. We're going to minus that and then plus that. So it should line up with the caps on the note now. And or not. It did the opposite direction. I need to add. It's odd that I would have to add instead of subtract, but I guess that's fine. There we go. Actually, the length being 0.5 seems a bit not right. Am I using a different shader? Touch note, hold note. I think I'm using the right one. Just trying to make it not take up the whole screen. There we go. Yep, so I think that's gonna be it for this stream. Made a little bit of progress on it. It's a little bit rough around the edges, literally, as you could see, potentially. But yeah, it's a good start, I'd say. Just need to change these to sign distance fields instead of just if statements. And yeah, so I think that's about it. Let me change my scene and have a good day.